Welcome to the Numerical Analysis course. In this lecture, we will be studying Lagrange's interpolation method. In the last lectures, we have been studying Newton interpolation method, the Newton forward, Newton backward, and Newton's divided difference interpolation methods we studied in last lecture. And we also studied that Newton's divided difference method is for unequal intervals, and Lagrange's interpolation method is also for unequal intervals in the data table where x has unequal intervals. X can have unequal intervals, and we know that interpolation means that given this table where we have x, y's, and y is f of x, we need to find some y naught corresponding to some x naught that is in between any two given values in the table. It can be between x1 and x2, can be between x2 and x3, can be between xn minus 1 and xn, can be anywhere between the two values present in the table. Right. The Lagrange's interpolation method says that for this x naught, f of x naught or y naught is f of x naught. It can be computed as del 1 times f of x1, y1 is f of x1, del 2 f of x2, y2 is f of x2, so on up to del n f of xn. How do we calculate these values for del 1, del 2, del 3? How do we calculate these dels? Del j, where j can be 1, 2, 3 up to any value n, it can be computed as, this is the product sign. Product sign means that if it is I from 1 to 2 xi's, this means x1 times x2. If it is 1 to 3, this is x1 times x2 times x3. Right, this is a sign for product. Right. So this means from 1 to n, we will multiply the ratios from 1 to n, but will ignore the value of I that is exactly equal to j. For example, let's compute del 1. We'll go from 1 to n, but will omit the term for I is exactly equal to 1. Right, let's start it. We go from 1 to n, but we have to skip 1, therefore we'll skip that. We'll go to the next value 2 to n, x naught minus xi, x naught minus xi, where we have started from 1, but we have omitted 1 at the same time. This means we'll start from 2. X naught minus x2 divided by x1 minus x2, where I is 2. And then we'll try the next value of I, that is 3. X naught minus x3, x1 minus x3. And finally the last value, x naught minus xn divided by x1 minus xn. But we have omitted the value for I is exactly equal to 1, because if you would do that, there would be a 0 in the denominator, x1 minus x1, and that would make things difficult for us. Therefore, we'll skip this. Right, what if we want to find out del sub 2? We'll go from 1 to n, but this time we'll skip 2 and we'll try all other values, x naught minus xi, x1 minus xi, x2 minus xi, since this is xj minus xi. So j is 2 here, therefore we'll replace j with 2. X naught minus x1, x2 minus x1, but we'll skip the next value 2 because that is equal to j. X naught minus x3, x2 minus x3, x naught minus xn up to x2 minus xn. How would you calculate del sub 3? We'll go from 1 to n, but this time we'll skip 3, and that would be xj, j is 3. So it's x naught minus x1, x3 minus x1, x naught minus x2, x3 minus minus x2. But the next term would be, it won't be x naught minus x3 because we'll skip 3. That would be x naught minus x4 divided by x3 minus x4. And the final term would be x naught minus xn divided by x3 minus xn. So in this case, we have skipped the term that has j is equal to, that has I is equal to 3, because if we would include that, that would make the denominator equal to 0, and that is what we want to avoid. So this is del 3 and the last was del 2, right? So this is how we can compute del 1, del 2, del 3, del 4, so on. We have to skip 1. When we compute del 1, we have to skip the term for which I is equal to 1. When we are computing del sub 2, we skip the term for which I is exactly equal to 2. That's all simple to calculate. All you have to do is you have to multiply these ratios together to find value of del j, where j is 1, 2, 3, 4. And finally, we'll plug these dels here. We have f of x is available from the table, these y's, and then we'll be able to find f of x naught. Right, so it seems simple. Let's solve it. Let's further understand it with the help of an example. And we know we have been solving an example for the last couple of lectures of sine of x, where we have this x and this y, 0, maybe 30 degrees, maybe 45 degrees, unequal intervals. Right, at 0 it is 0, at 30 you know it's 0.5, at 45 degrees it's 0.707, at 60 it's 0.866. So let's assume x naught to be equal to 10. Right, maybe here x naught is 10, and we know that sine of x naught, sine of 10 is 0.17 we studied last time. Right, so we are supposed to find this f of x naught or y naught. Right, but for that we have to compute some dels. How would you rewrite this whole expression? How would you rewrite this expression for f of x naught? Del 1, f of x1, because we have only 4 entries in this table. Del 2, f of x2 plus del 3, f of x3 plus del 4, f of x4, and that's all. We have to find 4 values for del 1, del 2, del 3 and del 4, and that's all. And we know n is 4 here because there are 4 rows in this table. So del j would be from 1 to 4 only for this case, because we have 4 entries in the table now, and that's all. And now we can find del 1, del 2, del 3 and del 4, because we'll have only 4 dels. Del 1 is from 1 to 4, where I is not equal to 1, x naught minus xi over xj is x1 minus xi. So we'll have, if we solve it, it would yield x naught minus xi. We are going from 1 to 4, but we are skipping 1. This means if we skip 1, we'll start from 2, x naught minus x2 over x1 minus x2, the first term. Then the next term would be for 3, for I is equal to 3, x naught minus x3 over x1 minus x3. And the last term would be x naught minus x4 over x1 minus x4. So we'll plug these values here. X naught is 10, x2, this is x, and these are the indices. This is x1, and this is I. This is 1, 2, 3, 4. x1 is 0, x2 is 30, x3 is 45, x4 is 60. So x2 is 30, x1 is 10, x2 is 30, x1 is not 10, x1 is 0, x1 is 0, x2 is 30, x0 is 10, x3 is 45, x1 is 0, x3 is 45, x0 is 10, x4 is 60, x1 is 0, and x4 is 60. So if you plug all these values in here, we compute del 1 to be equal to del 1 to be equal to 0.43. So del 1 is, let's write it here, it's 0.43. And next we are supposed to calculate del 2, where del 2 would be, let's first erase these values, because now we are going to compute del 2. Right, del 2 would be from 1 to 4, I isn't equal to j, where j is 2, this means I isn't equal to 2, x0 minus xi divided by x1 minus xi, that's all. x0 minus x1 here, x1, it's not x1, is x2, because xj is x2, x2 minus x1, x2 minus x3, x2 minus x4, and we'll skip the term for 2, I is equal to 2, and we'll plug these values from this data table, x0 10, x1 0, x2 30, x1 0, and if you plug all these values, del 2 comes out to be 1.29. So let's write it here, it's 1.29. And now let's compute del 3. Del 3 is from 1 to 4, but this time we'll skip 3. So that would be x0 minus x1, x3, because j is 3 here. x3 minus x1, x3 minus x2, and x3 minus x4, and we'll skip the term for 3 here, and then we'll plug these values from this data table. x0 is 10, x1 is 0, x3 is 45, x1 is 0, and going on this way, del 3 would be minus 0.98. Some of the values would be negative, some of the values would be positive, and finally it comes out to be minus 0.98. And finally, we compute del 4 from going from 1 to 4, but this time we'll skip 4. x0 minus x1, x3, it's not x3, it's x4. It's x1, x1 is x4. x4 minus x0 minus x1, x4 minus x1, x0 minus x3, x4 minus x2, x0 minus x4, x4 minus x3. So del 4 comes out to be 0.26. Right, and now we are going to perform the last step, that is to compute f of 10. F of 10 degrees is del 1, 0.43, multiplied by f of x1, that is 0, plus del 2, 1.29, multiplied by f of x2, that is 0.5, plus del 3 is minus 0.98, minus 0.98 multiplied by f of x3 is 0.707, plus del 4, 0.06 multiplied by f of x4, that is 0.866. Right, and if you solve this, it comes out to be 0.177. This is f of 10 degrees, and we know that from calculator sine of 10 degrees is 0.173. It's very close. So the value of the unknown f of 10, it comes out to be 0.177, and it is very close. It's in fact, it is very close to the actual value 0.173. So this means this method works. That's all for this lecture. Thank you.